Today we will be looking at example 2A6, and in this example it's given that a cable is wrapped around the inner radius of a spool. End A of the cable is moving to the right with a speed of VA. The spool is able to roll without slipping on a rough horizontal surface, and we are to determine the velocity of the center O of the spool and the angular velocity of the spool. We are given that VA is 2 meters per second, little r is 0.4 meters, and the distance of big R is 0.8 meters.
So now, starting with our solution, we remember that prior in class, we talked about different cases with no slip and on stationary surfaces. So this one, by looking at the problem, is going to be case 1. So with that being said, we know that the point that is on the stationary surface, the velocity is going to be 0, both in the I and in the j direction. So moving forward, first we're going to look for omega, because that is easier to find, and we're going to be needing that to find the velocity of point O. So first we use the velocity in the a direction. So our equation is velocity in the a direction equals velocity of point C plus omega cross r h/c. So we know that velocity of point C is going to be 0 plus omega, which is always in the k direction, cross whatever a/c is. So looking at our diagram, or the picture that was given, we can see that the distance isn't given, so we're going to have to make our own equation, which is going to be big R minus little r, and we know that that's going to be in the j direction. So once we cross omega and our distance, which is in the j direction, we get negative omega times big R minus little r in the I direction, and we can use that by doing the little triangle trick with k cross j gives us negative I. So since we're looking for omega, and that's our only unknown right now, in the equation we're going to rearrange. So our new equation is going to be omega equals negative velocity at point A divided by big R minus little r, which is going to be in the k direction. So once we sub the numbers in from our given, we get negative 2 meters per second over big R, which is 0.8, minus little r, which is 0.4, and we get negative 5. So our answer is negative 5 in the k direction, which is radians per second, and since it's negative, we know that our omega is going clockwise.
And now that we have solved for the value of the angular velocity, we can begin to solve for the velocity at point O. Now, using the velocity equation to solve for point O, we're also going to be using the velocity at point C, because we know that that's 0, and from there it's just adding the omega cross r of O/C, and then breaking that down into equaling 0 plus omega in k direction cross big R in the j direction, because we know that the big R is the same as the radius of the outside of the spool, which is O/C. And then to solve for the 0 goes away, then solve the omega cross R. We know that it is a k cross j, and using the triangle up here, we know that a k cross a j will equal a negative I, resulting in negative omega times big R in the I direction. Now, subbing in for the values there, we end up with the negative of the negative 5 times 0.8, which then results in the velocity at point O equaling 4 I meters per second.